Hi everyone, this is Maths4Uni. This is question 1E from MAT 2019. If you find this content helpful, then please consider liking and subscribing, as well as checking out our Udemy course. The link is in the description. The question says, the graph of sine y minus sine x equals cos squared x minus cos squared y. A is empty, B is non-empty but includes no straight lines, C includes precisely one straight line, or in D we have two straight lines, and in E we have infinitely many straight lines. So if we look at our equation, which is sine y minus sine x equals cos squared x minus cos squared y, then we note that if, for example, y equals x, then the left-hand side is 0 and the right-hand side is 0. Therefore, the equation is satisfied, and so, for example, the line y equals x is part of the graph. This means that answer A and answer B must be incorrect. Now we have to see how many straight lines are part of this graph. Is it C1, D2, or E, infinitely many? From the line y equals x, we noticed that both sides became 0. Can this happen for more relationships between y and x? Can we have sine y equals sine x and cos squared x equals cos squared y by picking y appropriately in terms of x? As we saw, if we pick y equals x, then this certainly occurs, but are there more straight lines, y equals mx plus c more generally, such that this occurs? We can see that there indeed are other straight lines by considering the periodicity of these trigonometric functions. For example, sine of x has a period of 360 degrees, if we're working in degrees rather than radians. Similarly, cos of x also has a period of 360 degrees. It turns out that cos squared of x also repeats every 360 degrees, but in fact has a period of 180 degrees due to the square. However, we won't need to use this, and all we'll need is that sine of x and cos squared of x repeat every 360 degrees. Therefore, the lines y equals x plus 360 degrees, y equals x plus 720 degrees, and so on, are also straight lines on this graph, because it makes both sides of the equation 0 by satisfying these equations. As a result, we can generate infinitely many straight lines, and therefore the answer is E. When seeing a question like this, it's worth being aware of symmetries and periodicities of the functions at play, because we have trigonometric functions. If you found this content helpful, then please consider liking and subscribing. Thanks for watching, and goodbye for now.